Welcome to today's maths class, and today we'll do pairs of lines and transversals. Our learning objectives are introductions, transversal, angles made by the transversal with two lines, parallel lines, distance between parallel lines, verification if the lines are parallel, angles made by the transversal with two parallel lines. So first one is introduction. In one of our previous chapters, we have studied about the points, lines, line segment, and a little about parallel lines, intersecting lines, and the perpendicular lines. In this chapter, we shall study more about parallel lines and their construction. We shall also learn about transversal, angles made by the transversal with two lines, and the relation between the angles made by the transversal with two parallel lines. So first is transversal. In geometry, a transversal is a line passes through two lines in the same plane at two distinct points. Transversal play an important role in establishing whether two other lines in the plane are parallel. The intersecting or transversal with two lines create various types of pairs of angle. In the following figure, line L is the transversal to the given line. Here, this line L, this is the transversal line. In all the figures, line L is a transversal line. Line M is not a transversal in the following figure because it intersects the given lines at the common point and not the different point. Remember that the given lines may or may not be parallel. Here, the line M, this is not the transversal. Why? Because it intersects the given line. ये जो है this line M that intersect the given lines at the common point, not at the different point. अलग-अलग point पे नहीं cut कर रही है, intersecting at the same point like here. So this is not a transversal. Next is angle made by the transversal with two lines. In the following figure, T is a transversal which intersect the line L and M at two different points A and B. The transversal is forming four angles with each line. Here, two lines L and M, and T is a transversal here. For our convenience, we name these 8 angles K1, K2, L1, L2, M1, M2 and N1, N2. Some of these angles can be paired together because the position they occupy. So first is exterior angles. The angles whose arm do not include the line segment AB are called the exterior angle. In the above figure, angles K1, L1, M2 and N2 are exterior angles. So angles which does not include the arm AB. So here K1, L1, M2 and N2. These are exterior angles. Next is interior angles. The angles whose arm include line segment AB are called the interior angle. In the above figure, the angles K2, L2, M1 and N1 are interior angles. Here, angles which include the arm AB are interior angles. So, in the given figure, K2, L2 and N1 and M2, these are interior angles. Interior angles are supplementary, means their sum is 180 degree. Next is corresponding angles. If the transversal intersect two lines lying in the same plane, then the pair of angle is said to be the pair of corresponding angle, provided both angle of the pair lie on the same side of the transversal. The pair consists of one interior and one exterior angle, and the angles do not form the linear pair. In the above figure, pairs of angle K1, K2, L1, L2 and M1, M2 and N1, N2 are the corresponding angles. So, corresponding angle K1 and K2, K1 and K2, L1, L2, N1, N2, M1, M2. These are corresponding angles. Next is alternative exterior angles. Other thing being the same as in figure 4 above, alternative exterior angles are necessarily exterior angle as shown in the figure 11.4. Here the pair of angle K1, M2, L1, N2 are alternative exterior angles. So, alternative exterior angle, they are K1, then M2 and L1 and N2, K1 and M2, L1 and N2 exterior angles हैं and alternative PA. So, they will call alternative exterior angles. Next is alternative interior angles. If the transversal intersect two lines which are in the same plane, then the pair of angles are said to be the pair of alternative interior angles, provided both the angles are interior, both the angles lie on the opposite sides of transversal and these angles do not form the linear pair. So, here if we talk about the alternative interior angle, so N1, L2, M1, K2, these are the alternative interior angles. So, in the figure 11.5, the pairs of angle L2 and N1 and K2 and M1 are alternative interior angles. Alternative interior angles are popularly known as alternative angles. Now, we will take an example. Observe the figure 11.6 carefully and tell if AB is transversal to lines CD and EF. So, here we have to tell if AB is the transversal to lines CD and EF. Here is the line AB. This is the line AB. So, AB is the transversal because it intersects the line CD and EF distinct point. अलग-अलग point पे intersect कर रही है A and B. So, this is a transversal. Clear? So, next is some important observations. A line which intersects two or more given lines at distinct points is called transversal to the given lines. Next is exercise 11.1. Subject enrichment. In which of the following figure the line L is the transversal to the other given line? In first figure, here this is the line L. So, here same point पे intersect कर रही है. So, this is not a transversal. Not a transversal. Clear? So, practice all the questions of this exercise. Next is parallel lines. Parallel lines lies within the same plane and are always the same distance apart. Parallel lines continue to infinity without intersecting or touching at any point. In geometry, a pair of parallel lines is represented by either a pair of single or double arrow as shown in the figure 11.101 and 2. We use the symbol. This is the symbol of parallel lines. Is represent parallel to. Thus, in the given figure 11.10, PQ is parallel to XY and AB is parallel to HK. Here, PQ is parallel to XY and AB is parallel to HK. Next is fact file. Two rays are said to be parallel if the corresponding line determined by them are parallel, a ray can be converted into line by extending it beyond its initial points. Two line segments are said to be parallel if the corresponding line determined by these are parallels. A line segment can be converted into a line by extending it infinitely in both the directions. Examples of parallel lines are opposite edges of ruler, railway line and this book. All these are the examples of parallel line. Next is distance between parallel lines. Unlike between the two intersecting or non-parallel lines, the perpendicular distance between the two parallel lines is constant everywhere. Means in whatever direction, how much we extend them, the parallel distance between the two lines will remain constant. It will not change. The perpendicular distance is also the minimum distance between two parallel lines. Let us verify this property of parallel lines. So first method, step 1. Place a ruler on the plain sheet of paper and draw two lines along its opposite edges. We obtain two parallel lines and name them as line MN and OP. Mark the point Q on the line OP. So, we have taken a ruler, place it here and draw two parallel lines. Two lines along the edges. So, we will obtain two lines. Name them MN and OP. Now we have marked point Q on OP. This is the point Q. Now place the upper edge of the ruler along the lower line OP as shown in the figure. Place a set square coinciding with the edge of the ruler so that one of the arm make the right angle at the point Q. Now draw the segment RQ along the edge of the set square as shown in the figure 11.12. Slide the set square along the ruler and draw more line segment STUV joining the parallel lines MN and OP. Step 5. Measure the length of RQ STUV. We shall find that all these line segments are equal. So what we have done? We have taken a ruler scale, place it on a paper and draw two lines. Now we have taken a point Q on it, take a set square, we'll move it along like OP, like this with O, it make the angle of 90 degree. Like this, we'll keep moving and draw line RQ, ST and UV. What we'll see? The length of RQ, ST and UV all are equal, means the distance between two parallel lines, the perpendicular distance between two parallel lines will always remain constant. Clear? So what is conclusion? From the activity, it followed that the perpendicular distance between two parallel lines is the same everywhere. The distance is known as perpendicular distance between the two parallel lines. Second method. There is an alternative method to verify the perpendicular distance between the parallel lines is the same everywhere. Step 1. Draw two parallel lines MN and OP as explained in the step 1 of method 1. This time take the different points T, U, V on the line OP. So here we have taken different points on line OP. Draw the perpendicular QT, RU, SV on line OP, joining line MN as explained in step 3 of method 1. Measure the three perpendicular and we shall find that perpendicular QT, perpendicular QT, perpendicular RU and perpendicular SV, they all are equal. So what is the conclusion? So conclusion is the perpendicular distance between the parallel lines MN and OP is constant everywhere. Clear? Next is verification of two lines are parallel. We shall proceed stepwise. We follow in order to verify two lines are parallel. Step 1. Draw two parallel lines with the help of a ruler as explained earlier. Name them AB and CD. Mark the point O, P, Q on the line CD and draw the perpendicular from these points on line CD touching line AB at point R, S and T respectively as suggested in step 3 of method 1. Measure three perpendiculars. So, here we have drawn two lines AB and CD with the help of ruler. Now, we have drawn three perpendicular taking different points and drawn three perpendicular. Now, we will measure all the three perpendiculars. What will we see? So, conclusion is, if all the perpendiculars are equal length, then two lines are parallel. If all the perpendiculars are not the same length, means two lines are not parallel. Next is some important observations. Lines in the plane which do not intersect are called parallel lines. The distance between the two intersecting lines is 0. The distance between two parallel lines is the same everywhere and is equal to the perpendicular distance between them. Next is exercise 11.2. Subject enrichment. In figure 11.15, line segment AB and ray CD not intersect each other. Can we say that they are parallel? Give reason for your answer. No, we can't say that these two lines are parallel because the perpendicular distance between these two lines keep changing. It is not constant, means they are not parallel to each other. Clear? Practice all the questions of this exercise. Next is angle made by the transversal with two parallel lines. In the figure 11.161, the line PQ is the transversal. The line KL and MN are two parallel lines. The angle K1 and K2 are called the corresponding angles. Corresponding angle S. Similarly, L1 and L2 are also called the corresponding angles. Use your protractor to measure the angles K1, K2, L1 and L2. What do you notice about the size of the angle K1 and K2, L1 and L2? Can you name two other pair of corresponding angle in the figure 11.162? So here, K1 and K2, L1 and L2, these are corresponding angles. Here, if we take angle A1 and A2, so A1 and M2, they are corresponding. A2 and N2, they are corresponding. The given figure 11.162 shows that the parallel line MN and OP cut by the transversal AB. The angles M1 and M2 are alternate angles. Similarly, N1 and N2 are also called the alternate angles. Use the protractor to measure the angles M1, M2, N1 and N2. What do you notice about the size of angle M1 and M2 and N1 and N2? So, we will observe that these are equal. Now, observe the figure 11.163. In figure 11.163 shows two parallel lines AB and XY cut at the transversal PQ. The angles A and B are interior angles. The angle X and Y are also interior angles. Use your protractor to measure the angles A, B, X and Y. Find the value of A plus B and X plus Y. Are the interior angles supplementary? From the above discussion, we can conclude that when two parallel lines are cut by a transversal, the corresponding angles are equal. Corresponding angles equal honge. The alternate angles are equal and the interior angles are supplementary, means their sum will be 180 degree. The converse statement for the above is also true, means if the corresponding angles are equal, the line is parallel. The alternative angles are equal, that means the line is parallel, and the interior angles are supplementary, that means the two lines are parallel. Clear? When two straight lines are cut by a transversal and if the corresponding angles are equal, then two lines are parallel. If the alternate angles are equal, then two lines are parallel. If the interior angle is supplementary, then we can say that two lines are parallel. Now we will take an example. Find the unknown angles in the figure 11.17 in which AB and CD are two parallel lines and PQ and RS are the two transversal which cut them. So here two angles are given, 48 degree and 61 degree. So the corresponding angle हो जाएगा angle A. So it will be 48 degree because corresponding angles, if lines are parallel, corresponding angles are equal. So angle A would be 48 degree and E would be 61 degree. Clear? Here angle C and angle E. Angle C and E 180 degree हो जाएगा because they are linear pair. यहाँ पे हो जाएंगे supplementary हो जाएंगे 180 degree. Then angle C equals to हो जाएगा 180 minus 61 degree, that is 119 degree. Next, angle B and E. Angle B and E, they are alternative angle. Alternative angle equal होते हैं, so that is also 61 degree. Then D, B and D, they are equal. They are corresponding angle. So that is also equal to 61 degree. Practice all these examples. It will give you better idea to understanding the concept. You have to practice all the examples. Next is some important observations. If two parallel lines are intersected by the transversal, then the angle of each of the corresponding angles are equal. The angles of each pair of alternate interior angles are equal. Interior angles on the same side of transversal are supplementary. If two non-parallel lines are intersected by the transversal, then none of 1, 2 and 3 above is true. If two lines are intersected by the transversal, then they are parallel if any one of the following is true. The angles of the pair of corresponding angles are equal. The angles of the pair of alternate angles are equal. The angles of the pair of interior angles on the same side of transversal are supplementary. Next is exercise 11.3. Subject enrichment. In figure 11.24, line AB is parallel to line CD and RS is the transversal intersecting AB and CD at P and Q respectively. If angle PQC 35 degree, find the angle RPB. So here line AB is parallel to line CD. AB is parallel to line CD and RS is transversal. So angle PQC, angle PQC, this is given 35 degree given to us. We have to find the angle RPB. RPB, this one. Clear? So if this angle is 35 degree, that means its corresponding angle, this one, this will be also 35 degree, and these are linear pair. So 180 minus 35 degree, 5, 4, 145 degree. So मेजर कितना हो जाएगा 145 degree. Clear? Next is let's recall. Take the correct option. Two parallel lines are everywhere the same distance apart. Yes, that is true. So A is the correct answer here. So here we end the chapter. I hope you understand it well. Now you to practice it.